Hi guys, I am from ACM student chapter IIT ISM Dhanbad. I'll be discussing this problem of June circuits from HackerEarth. The name is the maximum number. Okay, the problem goes as you are given an array n A of n elements and they have defined a function f of x as the bitwise AND of x with all the elements and the sum of it, right? So we need to find the number of values of x for which f of x is maximized, the number of distinct values, right? One constraint that they have given for x is that there have to be exactly L set bits in its binary representation. Now, what do you mean by set bits? It is the number of 1 in the binary representation of x should be equal to 1. Sorry, should be equal to L. Okay, good. So, and if there are infinite values of x, then just print -1. Okay, it won't be greater than 10 to power 18 they have given. Let's analyze this problem with the sample test case that is given to us, which is this. So I'll take this array and I'll write the bitwise representation. I've written it. Okay, and okay, suppose, and this is my number x. I don't know the value of the bit at this position, right? Clear. Good. So suppose if this is a 1, if this bit is 1, bitwise AND of x with all the numbers, what will it do is that 1 and this thing will give me 1, it and with this thing will also give me 1, and with this number it will also give me 1. So the total number of times it is giving me 1 is 3, right? And the decimal value which is added to f of x because of it is 4. Every time 4 is being added because it is 2 power 2, right? So its total weightage, the weightage of this set bit in f of x is 12, right? Good. Now suppose if this is 1, then its contribution will be the number of times 1 occurs at that position, so which is 2, right? And also its weightage is also 2. Good. So the total contribution by this set bit will be 4. Similarly for the last one, the number of times it is happening, 1 is occurring at this position is 4, and each time the weightage is 1, so its total contribution will again be 4, right? Great. There are, in this case, they have asked us that there should be exactly two values, two set bits in x. Okay, so what will I do is, first I'll select the maximum L numbers which are contributing to this f of x. So for that, what will I do is, first sort this in descending order, right? Great. So it is already in descending order, so I'll write it down once, this thing, right? Now we have to select the maximum two elements, right? Maximum L elements. In this case it is 2, so I'll select these two. Now wait a second, why only these two? Why can't I select one this and one this? Okay, so what we are doing is, I'll select this element, and for this the next element, it is any one from these, or basically I can say 2 2c1, right? Okay, if I take this as a case, suppose this array is 12, 4, 4 and 4, 4 and one more thing, 3, right? Good. And we have to select our L value as they have given us the L value as 3, right? So first we'll select this 12, undoubtedly. Now out of these next three values, the remaining values we have to select is 2. So anyways we are not going to select this 3. So out of these remaining three values, we have to select 2. Reason is because our x value is different in all cases, whereas the f of x value or the maximum value is remain same, right? It hardly matters if I take these two 4s or these two 4s or this 4 and this 4, right? Okay, so what will I do is count the total number of count the occurrence of the element at the position L, right? Like in this the third position, I'll count the total number of occurrences. In this case it is 3. Okay, and how many such numbers do we want? I'll count that thing also. So in this case it is 2. So what I'll do is simply 3C2. Okay, acha. Suppose now we'll see the case when -1 will come as the answer. Suppose if L value is 6. Okay, what will happen is the maximum set bits that we can give to it is 1, 2, 3, 4 and 5, right? This can be the maximum value of x or the only value of x, right? But since L is 6, now one set bit is remaining. That means prior to this I can apply any number of zeros or even zero number of zeros and add that set bit, because these things won't contribute to the f of x, है ना? Okay, so basically we are producing some infinite values. Okay, so what the condition for this -1 is if L value is greater than the total number of non-zero values in this array, then we'll say that we'll simply say that infinite answers are possible, so we'll just print -1. Okay, now let's look at the implementation of the code. I've selected this array A, input the numbers and fill this array B. Now what is this array B is the contribution of each of the set bit, right? So this is what I've done here. Okay, now I've calculated if the number of non-zero numbers, if the number of non-zero numbers in B, if it is less than L, then I'll simply print -1 because there will be infinite cases. Okay, and this is the contribution array. This is the contribution array which was this thing in our example, right? So I'll just multiply. I have just multiplied it by 2 to the power I, है ना? Okay, then I am sorting it in descending order, sorting the contribution array in descending order, and then I'll calculate the total number of occurrences of the value at A of L, or sorry, C of L, right? C of L -1, the Lth position, है ना? So this can be either prior to that position. For example, in this case L is 3, so this 4 can come to the left side or to the right side. So I've just calculated the total both the positions, and this is for the NCR of it. The NCR, as I have explained here, 3C2 or 2C1. So this is just a simple code for NCR, and that will be the answer for it. I hope you guys understood the solution and liked it. So please subscribe to our channel and do share it with your friends, and if you have any doubts then post it in the comment section. Thank you.